In late 2022, artificial intelligence burst into public view. For millions of people trying out tools like ChatGPT for the first time, it felt as though a spontaneous technological miracle had simply materialized out of thin air. But that sudden explosion of generative AI was actually the finish line of a grueling 80-year computer science marathon. The foundation of this technology was laid decades ago, stretching back to the 1940s and 50s. Pioneers like Alan Turing first proposed a seemingly impossible question: could machines be built to think? To understand how artificial intelligence reached the device in your pocket, we have to look at the periods where it completely collapsed. Over the last century, the entire field was practically left for dead, twice. Recognizing AI as an 80-year survivor provides the necessary background to assess current technical claims and the various theories about where the technology might be heading next. In the 1960s, researchers writing early code on massive, room-sized mainframe computers were wildly optimistic. Programs were successfully solving algebra problems and proving logic theorems, leading many scientists to predict human-level machine intelligence was only a few decades away. This animated chart tracks AI expectations over time, and you can see the initial optimism spike in the 60s. But watch as the line drops into a steep trough labeled the 1970s. Those early models failed outside controlled laboratory environments. The computers of the era were simply too slow and lacked the memory to handle complex tasks, causing government funding to dry up. The timeline spikes again in the 1980s. Researchers returned with expert systems, programs designed to use rigid, rule-based logic to handle specific tasks, like financial analysis and medical diagnosis. But as the graph shows, another steep crash followed in the 1990s. Expert systems proved incredibly expensive to maintain and failed when faced with unpredictable real-world situations. During this period, the alternative concept of neural networks, mathematical models roughly inspired by brain cells, was actively mocked by many in the field as a dead end. These repeated cycles of financial ruin and collapsed expectations forced scientists to abandon rigid hand-coded programming. They needed an entirely different approach to computing to make machines learn. While official AI research sat frozen, the exact infrastructure required to save it was being built by entirely unrelated industries. The first major push came from 1990s video games. To render 3D graphics rapidly, the gaming industry developed powerful video cards, or GPUs. Researchers later realized that the exact mathematical architecture used to draw millions of geometric polygons on a screen was perfect for processing the complex calculations required by neural networks. At the same time, the internet shifted data collection from physical paper to digital files. These workers using desktop terminals represent the beginning of the massive datasets, images, text, and code that would serve as the raw training material for neural networks. In the background, classified government defense budgets continuously funded projects in cryptography and language translation, keeping baseline computer science moving forward even when commercial interest vanished. The collision of gaming hardware, internet-scale data, and steady defense funding unintentionally created the perfect incubator for artificial intelligence to rise again. The turning point arrived in 2012. Researchers deployed a deep neural network called AlexNet, feeding it massive amounts of internet data and running it on gaming GPUs. It shattered all previous records for image recognition accuracy, proving that deep learning actually worked. 4 years later, Google DeepMind's AlphaGo defeated the world champion of Go. Because Go is a game heavily reliant on long-term strategy and human intuition, a machine mastering it shocked scientists worldwide. Then, in 2017, researchers published a paper titled "Attention is All You Need." It stands as one of the most influential breakthroughs in modern computer science. This paper introduced the transformer architecture. As seen in this abstract visualization, a transformer doesn't read data in a rigid, linear flow. Instead, it dynamically weights and connects different parts of a sentence all at once. This mechanism efficiently processed massive language models. Instead of flawlessly copying human logic, AI succeeded through overwhelming computational scale and mathematical pattern recognition. This validated the exact neural network theories that had been heavily mocked decades earlier. Despite how conversational these tools are, their internal mechanics are only loosely inspired by biological neurons. Current machines possess zero self-awareness, no emotions, and do not truly comprehend the text they generate. This image shows a modern data center, which illustrates what AI actually is today, a highly advanced mathematical pattern predictor. Relying on massive server facilities, it uses decades of data processing to simply guess the most statistically likely next word or pixel. We are interacting with these massive models every day on our phones, yet experts estimate we are only in the early 1990s internet phase of this technology's development. This leaves us facing a massive unknown variable: whether artificial general intelligence, a system capable of matching human cognitive abilities across all disciplines, is actually achievable. Technological progress relies on these repeated patterns of failure and persistence. Today's generative tools represent the latest spring in an 80-year cycle that is far from over.